Unpacking the Victorian Senior Mathematics Curriculum. Our focus today will be on the overview of the revised 2016 to 2018 Senior Mathematics courses for Victoria. In particular, we'll be focusing on the changes and the revisions. Next, we'll be looking at possible implications and suggestions for current Year 11 studies. And today, our main host will be Frank Moyer. He's going to do most of the presenting, and he'll be sharing with us some of his views, and those views are our own personal views, not necessarily those of the VCE or VCAR. Okay, so I'll transfer over to Frank in just 1 second. Are you there today, Frank? You there, Frank?
Yes.
Okay, so I'll transfer over to you so you can kick us off. We've got a huge amount to get through, as people can appreciate, with the further methods and specialist courses to articulate. We've got a lot of people on board and there's a lot of questions, so if I don't get to answer your question during the webinar, then please forgive me, because there's a lot of people asking questions. Okay, so you want to share your desktop there, Frank, and we can kick it off.
Okay, so you can see my desktop now?
Not yet. Try that. Either that or go through your share menu on the little WebEx icon, little blue globe down the bottom. Just while Frank's getting his desktop up there, just a reminder to people, at the top of your screen it will say something like viewing Texas Instruments desktop or viewing Frank Moyer's desktop, and in that section you can bring up a chat space. So if you hover over the top of it, you'll see that there's a little chat option. There's also a question option, and you can bring either one of those by clicking on them and sending questions to either myself or Frank, and as I said before, we'll make our best efforts to respond to them. Okay, I can see your desktop now, Frank, and your first slide, and we're good to go. Thank you.
Okay, well, welcome everyone. First of all, as Peter said, this is only an overview of the revised studies and some ideas on what teachers might do this year to prepare their students for next year. It's my understanding that later on in the year, Texas Instruments will be running subject-specific PD to cover the new content. Now, some of the references that I've used in preparing this presentation, and all of these were certainly working today, these links here, I understand that the PowerPoint will be available for you to download after the presentation, so you'll be able to go straight to these links. In particular, I point people's attention to the study advice that was issued earlier this year by the VCEE. Okay, let's move on. Now, revised studies. First of all, I'd like to emphasise that the new Victorian curriculum, senior curriculum, is a revised version of the current VCE study, even though there are many similarities and commonalities with the ACARA Senior Mathematics Australian curriculum. It is certainly not the same thing. A lot is in common, but it's a uniquely Victorian curriculum that is being implemented for 2016 to 2018. Now, the structure. There haven't been a lot of structural changes from the current study design to the new one, but I thought I might point out some of the slight differences. Foundation Mathematics continues in its current form. Now, General Mathematics, it's been designed specifically so that different implementations are possible. You might have an implementation to prepare students for further maths, or to support mathematical methods, or to support specialist maths. Now, that will continue, except that under the current study, under the current study design, students who are doing a specialist maths implementation do not get any special credit, whereas in the revised study, students who do the 4 prescribed topics will be able to get credit for Specialist Maths Units 1 and 2. So rather than thinking of Specialist Maths Units 1 and 2 as being something that must be done in order to do Specialist Maths 3 and 4, think of it as the equivalent of the current Specialist Maths implementation of general mathematics, similar to sample courses 3 and 4 in the current study design. With regards to Mathematical Methods CAS, which is the name of the current study, that just becomes Mathematical Methods. The CAS now becomes redundant because we no longer have dual implementation as we did earlier. Now, the other structural change is with regards to further mathematics, where currently 40% is core and it's fully prescribed and it involves data analysis with 6 modules from which 3 are selected. So we're going from a 40-60% split to a 60-40% split, with the addition to data analysis in the core of also having recursion and financial modelling. The modules are going from 6 modules from which 3 are chosen to selecting 2 from 4. With regards to Mathematical Methods 3-4, I guess the major change is that the probability area of study becomes probability and statistics, and statistical inference for proportions has been added to Mathematical Methods. With regards to Specialist Maths 3-4, we now have a new area of study, probability and statistics, where the main focus there is sample distribution for sample means and hypothesis testing. And we'll talk a bit more about that as we go on. As to what combinations of units students can do, this is straight from the study design, and I'd just point out that, as is currently the case, Mathematical Methods 1-2 is sufficient for students to be able to do Mathematical Methods and Specialist Maths. However, obviously, they'll be much better prepared if they've done some additional work in order to do Specialist Maths 3-4. Now, entry into VCE units. This is straight from the study design. There are no prerequisites for entry to Units 1, 2 and 3. However, students undertaking Mathematical Methods Units 1 and 2 or Specialist 1 and 2 are assumed to have a sound background in number, algebra, function, geometry, probability and statistics. In other words, that they have covered all the necessary material from the VELS or the AusVELS or Australian Curriculum Level 10. And enrolment in Specialist Maths 3 and 4 assumes current enrolment or previous completion of Mathematical Methods 3 and 4. Now, I want to talk a little bit about Specialist 1 and 2 because there is, in speaking to teachers, there is a misconception among some teachers that Specialist Maths 3 and 4 cannot be undertaken unless students have undertaken Specialist 1 and 2 first. So, as it says in the study design, it has the same, Specialist 1-2 has the same flexible structure and areas of study as General Maths 1 and 2, with a combination of prescribed topics, so there are 4 prescribed topics, and topics from which there is choice. Now, the prescribed topics are number systems and recursion, geometry in the plane and proof, vectors in the plane, and graphs of nonlinear relations. So provided that students have done those 4 topics, whereas currently students would only be getting credit for doing general maths, even though they've done a specialist preparation, in the revised study, provided they've done those 4 compulsory topics, they can get credit for Specialist Maths 1 and the other topics can be chosen from the new additional material, or they can be chosen from any of the general maths topics. Now, this is the specific study advice which I referred to earlier that was released by the VCEE earlier. So, as is currently the case, the revised specialist maths units 3 and 4 assumes a concurrent enrolment in all previous completion of methods 3-4. The assumed knowledge for methods 3-4 is obviously 1 and 2. Now, as is currently the case, familiarity with certain material is assumed for students who are going to be undertaking specialist 3-4. However, it is not assumed that students will have undertaken an implementation of general maths 1 and 2 intended to provide additional preparation for various topics. And to me, a corollary to that is that beyond 2016, it will not be assumed that students have done specialist 1-2 in order to do 3-4. It will certainly be extremely useful, and perhaps students would be advantaged, but it's not going to be assumed.
And I think in the past, Frank, the wording was something like it was recommended that students do the general maths 1 and 2 in preparation for specialists, wasn't it? That's
right, yes. So I think my understanding is that pretty much the same applies. That whilst it would be extremely helpful and it would be recommended that students do specialist 1 and 2, students who have not done it are not prevented from going on and doing specialist 3-4, as is currently the case.
Yeah, and just another one which came in as a question before, and I'll kind of paraphrase. In a school that, say, for example, had students doing 2 lots of maths in Year 11, and I know some schools do it, I used to teach at one, where they might be using the general maths to support those students doing both methods and or specialists. That would obviously be fulfilled by those elective sections of the specialist 1-2 course. Is that how you would read that?
Yes, that's how I would see it as well.
So they could use those electives to support the sorts of content that they might be coming up to in their methods course. A little bit like, I was trying to think of rates of change sorts, I don't know if that's the right term. I think it was there velocity time graphs and distance time graphs and all those sorts of things you could do in general maths which would support the kids' understanding of calculus ideas.
Yes. Yeah.
Kinematics, that's the word I was looking for.
Yeah, absolutely. Okay. Now, first of all, I thought I might go through, summarise some of the major content changes from the current study. Not all of them. I thought I'd perhaps just stick to the major ones. In foundation maths, I see the difference that it's now envisaged that there could be a pathway from foundation maths to further maths by just treating some of the topics with some greater depth and some judicious selection of supplementary content. So whereas in the past we've seen foundation as being a dead end, now the possibility of moving on to further maths is certainly open in the new revised study. In general maths 1 and 2, the main difference is that all of the topics which are there in the current study design have been repackaged, if you like, into the following areas. So the areas of study are now called algebra and structure, arithmetic and number, discrete mathematics, geometry, measurement and trigonometry, graphs of linear and non-linear relations, and statistics. So even though the content is much the same as in the current study, it's certainly been packaged a little bit differently. Incidentally, the specialist maths 1 and 2 has exactly the same areas of study. Now, further mathematics, that's the other area where there has been a major change, with the core now having not only the data analysis, which is there now, but also this new recursion and financial modelling with the relative weightings of 40 and 20%. Now the applications area of study, in other words the modules, it's now, as I said earlier, comprises of a selection of 2 modules from the 4 available. Now the modules, matrices, networks and decision maps, geometry and measurement, graphs and relations. Now even though those modules that people are familiar with, there have been some changes to the modules as well. So in the case of matrices, it now includes a broader range of matrix types that can be used in modelling with simple recurrence relations. And the geometry and measurement module also incorporates some spherical geometry with applications to the Earth's surface, so things such as relating changes in longitude with time zones and so on has been included. Now, this recursion and recurrence relations, what are these about? Well, this is what the study design says about this new topic. So this topic covers the use of first-order linear recurrence relations and technology, and it's interesting that they've explicitly said technology to model and analyse a range of financial situations. So what is recursion? Well, there are some formal definitions that you can find on the web, but basically a recursive process is one where you get the next term in a sequence by applying a rule to previous terms in the sequence, having established some initial values. And Peter's going to show us some really good applications of this using TI-inspired technology. What about this recurrence relation? So recurrence relation, I guess, is a rule that tells you how to go to the next value in the sequence from the previous value, or from the initial value to the next value. Now, for teachers who are familiar with Module 1 in the current study design, or the number patterns module, there is, there they refer to difference equations. Now, I noticed that in the new study design, the recurrence relation is used in preference to difference equation. And perhaps that's because by talking about relations, it emphasizes multiple representations of the recursion, not just an equation. The equation is just one way of looking at the rule. And that's where I'd like to handball to Peter, who's got some really good examples of recursion using TI-inspired. So over to you, Peter.
All right, thanks, Frank. So what I'm going to try and demonstrate here in the time that we have available, and as I said, we do have a lot to get through, so we'll see how we go. Now, are you seeing my desktop yet? Just try this. So what we're going to try and do is illustrate the sorts of examples, and we're bearing in mind, of course, that these students are in further maths. They're not doing a high-powered level of mathematics in terms of calculus or anything like that. So we'll start with some really simple ideas that could be turned out on a basic scientific graphics CAS type calculator, where if I just enter a value and I say, well, I'll add 1 to my previous answer and press enter. Now, of course, if I keep on pressing enter, what it does is continues to use the previous answer. So that's the simplest form of recursion that we've got, where the current answer is dependent on the previous one. Now, the next thing I'm going to show you is an example here, and this is the sort of thing that you might do in anywhere between Year 7 and Year 10, depending on the level of algebra of your students. It doesn't have to be on Inspire, it could be just using building blocks. So we're just following a pattern or a sequence, and the students generally describe that algebraically. Now, in the junior levels, we'd anticipate seeing a y equals, or in this case, the number of squares is equal to something times a number of shapes. So the algebraic rule for this one might be squares is equal 2 times the number of shapes minus 1. Now, the difference that we've got in the use of recursion, let me just bring that slide up, is this sort of notation, and that might scare some students off unless you lead them into it delicately. So my suggestion to lead them in that way is to start with a spreadsheet, because we see those sorts of terms of reference immediately on a spreadsheet. Let me give you an example. So this cell is cell A1, this one is cell A2. The only difference, of course, is we're getting a subscript when we're looking at that rule. So I can type in things like A1 plus 1, and it will vary depending on what was typed in previously. So if we start with 1 and we make our rule refer to the previous value, so our rule is simply the previous number plus 1, and then we can fill down. So in this example, this might be my shape number, and I noticed that when there was only, when the shape number was 1, I had 1 block, and you may have noticed that when the blocks were being added, they were a different colour. So it's equal to the previous amount, that would be B1, plus 2 extra blocks each time. So even if the students haven't been able to come up with an algebraic expression, the idea of this recurrence is to say, well, can you refer it back to the previous model? Yes, we can, and that same rule applies, and we get that sort of pattern. And they can go back and cross-check with the actual blocks or the puzzle that they're doing. That gives us a rule that looks something like that. What we've done here is put it as a scatter plot. Now, the sequence aspect of it, and if you're not sure where that can be brought up from, on the calculator, we just change across to sequence. We've got a couple of different ways we can do it. So we're just going to use this method, and we can say, well, it's the previous amount plus 2. We need to put an initial condition. Because we're referring back to something that was there before, we've got to know where we started from. Well, there was 1 block at the start, and it looks as though it hasn't plotted, but it actually has. Let me just go back up the top. You'll see it's in blue. Let me change the colour of that. Must use U1. Oh, sorry, thank you, Russell. I saw a note in there. I did. I missed off the U1. That's why I haven't plotted. There we go. And then they've plotted all of those points in that sequence. So, thanks for the tip there, Russell. U1 is equal to the previous U1 plus 2 with an initial condition of 1. So that's our first example, and if we wanted to, we could represent it in that way, the explicit solution. So in other words, if I don't want to know all the previous ones, then I can put in my start value and jump straight to the 10th or 20th term, and students may be familiar with that with arithmetic sequences. The second example I'll show quickly is a recurrence relation. This is one that I used to do, strangely enough, with Year 11 method students, but it's a really simple way to get the students understanding it, and that is we'd fill up a container full of M&Ms. 100 is usually a good number to start with. I think I've chosen 200 in this example. You put the M&Ms in the container, shake them up, pour them on the desk, count how many there are, and then the kids get to eat all the ones with M facing upwards. We'd expect that they'd eat approximately half of them, and then they stuff them back, the ones that they haven't eaten, they put them back in the container, shake it up again, and eat them. And as you can see, they gradually disappear. And in this case, the sorts of recurrence rule that we're talking about, a relation, is a multiplication of the previous term. So we're halving the previous term. So if we start with 200 M&Ms, then we'd expect to have the previous amount times a half. So after one rolling of the cup and eating of M&Ms, we get to eat 100 of them. Next time we'll roll 100 M&Ms and perhaps eat 50 of them, and then 25, and so we go. and we see that we get, in this particular case, an exponential decay. Now, Frank referred, I think, before that this is largely related to financial modelling. You can see a lot of really cool examples of this in the taxation guidebook, believe it or not, for things like depreciation of value. There's declining value, and then there's capital value. So you can depreciate items in various ways. So that's that example there. And in this case, we could also write that in a rule that would be more familiar to perhaps students of methods, writing it as, say, 200 times a half to the power of x. So exponential models, geometric sequences, and the last one I want to show you, and I'm just making sure we try and get through this in time, is a recurrence relationship, and we kind of combine both the previous ideas. And there's a lovely example that Frank pointed out to me that is on our website, our Tower of Hanoi problem. Let me quickly demonstrate that. Some schools will actually have this model, if you like, in their school already. Now, the idea here is if I move a small disk, I can't put a big disk on top of it, it won't let me. So small disks on top of big disks, and so we go. And the idea is to get all the disks moved from one column across to the other. Now, this is a lovely example because I'm thinking, oh, am I ever going to finish this problem? I've taken 7 moves to take the top 3 disks off. Then I will move that one across. That's one more move, and now I've got to move all these back on. Well, based on what I did before, that's another 7 moves, so I already suspect I'm going to end up with 15 moves before I finish the problem. And there we have it, 15 moves. Now, of course, the idea of that one is that they could use a spreadsheet to do the same sorts of things. If we have the number of moves in here, or the number of disks in here, then the first one, takes 1 move, then the next one is 2 times the previous value, because we have to shift those top group of disks out the way, move the bottom one, and then move them back. And the plus one is the movement of the very bottom disk. So there it is for 2 disks. There's the 7 for the 3 disks. There's the 15 for the 4 disks. So that, in essence, is the recurrence. The idea of linear, it doesn't look like a linear graph, but that's not what the linear is referring to. It's the fact that our variables here, the u, un, does not have any squared or power terms on it. First order, just meaning to the fact that it only refers to the previous value. The most common second order recurrence model people would have seen is a Fibonacci series, where you can obviously refer to the previous 2 terms, add the previous 2 to get the next. So that's a quick demonstration on what we mean by linear first order recurrence. I think I went as fast as I possibly could there, Frank, so I'll handball straight back to you so you can continue sharing. And as I said before, if you have any questions for us, keep those questions coming in. I'm typing as fast as I can to get them all answered. So if you want to share your desktop there, Frank, we'll be back and running again.
Okay, so you can see that?
Yep, you're up and running. Thanks, Frank.
Thank you. Okay, welcome back. So these slides are just what Peter has already gone through. Okay, so summary of major changes. Let's move on to Mathematical Methods Units 3 and 4. So there is some removed content to make room for the new content. So first of all, Markov chains, sequences and transition matrices are out. Matrix representation and solution of simultaneous linear equations. Now, teachers can still choose to do this method if they choose, but it's no longer required. Absolute value function and all that's related to that is out. That's been moved to specialist maths. The linear approximation of a function, which hasn't been on the exam for a few years. related rates of change, which is an interesting one. That's, once again, that's now in specialist, but not in methods. And mode and median of discrete probability distributions. It's still there for continuous probability distributions, but not for discrete. So that's what's gone out. So what's been added? Well, the probability has now gone to probability and statistics area of study with the new topic, sample proportions and confidence intervals. Okay, so the next bit is what might teachers do to get students ready for this new topic with statistical inference for proportions? Well, this is the study advice that came out earlier in the year. So for 2015, teachers do not need to include material on transition matrix and Markov sequences or chains. So you now have the OK from the VCEE, and I've given you the links in that second slide where you can see the official communique from on their website. They're giving you permission not to cover that material in 2015. And instead, with respect to the current Unit 1 bullet point, which refers to display and interpretation of results of simulation, basically you're being encouraged to ramp that up. So do more on simulation, and in particular simulation related to random sampling. So the idea is for students to look at variability when you take samples. So if you take a sample from a population, there is variability. So the sample proportion, for example, or the sample mean will change from sample to sample, and it's looking at that variability, that distribution, that is important. So in doing more on this topic of simulation, and the technology, TI-inspired technology is excellent for this, as Peter will demonstrate, is not only preparing students for probability and statistics for methods, but also for specialist 3 and 4. Okay. So what teachers might do in 2015 using TI-Inspire. So once again, looking at sampling distributions. Now, Peter has got a really good example showing sampling taken from a population of 25 students. So can I get you back, Peter, to show us that?
I can do that. I'm just about to share my desktop there. Thank you, Frank. So this one is an example. Where are we? We've lost him. Come back here. I think might appeal to students. So Alex gets his test back from his teacher and he wants to know, how did I do? While he knows his current score, you can see that is written on his test, he's interested in how he went in relation to the rest of the class. So as his teacher won't divulge such information, he decides to ask some of his friends. This is not dissimilar to what students would do naturally anyway, which is why the question appeals. So he asks a couple of his friends and takes an average and says, not too bad, I was about average, or might be slightly above or slightly below, depending on which friends he chose and also obviously his score. So to get a better idea, he thinks, oh, I'll go and ask some more friends and see what I can get from them. So we want to simulate this. So let's demonstrate. Now this file will be available on the downloads after the webinar is finished. Give us a day or two to get the files up there. There's a little bit of text on the first page, but here's where the fun starts. The blue scores down the bottom here, well, that's all Alex's classmates. That's the population in this case because he's interested in how the class went. So the students in his class represent the population. He doesn't care less about the other classes, if there are any. So we see that Alex has asked a couple of his friends, and we got an average of 143 over 3, which looks a little bit sad. Alex is hopefully up on the top end of that. So he's happy at the moment because he's better than the average of his sample. So we can take another sample. We can ask him to pop in another sample, and you can see the second sample is somewhat different. That's what Frank was talking about, the variability of samples. So this is the mean of 3 of his friends. This is the mean of another 3 of his friends or classmates. So we can perhaps take another group of 3. And you'll also notice that here we've got the mean of the actual population coming in, and then the mean of his sampling distribution. So that's not the mean of just one group of 3 students, that's the mean of the 3 samples that he has taken so far. Now he's taken 4, and rather than me sitting here click, 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 we'll get it to animate. So it was just a right click on that little slider there, and now he's taking lots of samples. He's obviously very busy running around his classmates. One could argue that he probably should have just asked the whole class to surrender their results, but in a real example, we're talking about much larger populations where it's not reasonable to ask everyone. But you can take samples and you can see all sorts of concepts coming out here, such that the sampling mean, or the mean of the samples, actually becomes less volatile with the more samples that we take. We can see some sort of symmetry about the actual samples that we've got. We can see that there's some values lying down the bottom end, an unlikely one down there, and an unlikely one up here, where perhaps the sampling could have the top 3 or the bottom 3 students, and most of them falling around about the middle. And in fact, some students already pick up, depending on what other studies they're doing, if they're doing biology, for example, may already be able to identify that that's a normal distribution, or at least looking approximately normal. So I can stop that animation. It's designed and set up so that if I hit the reset button, we can start sampling again. So that's our sampling distribution. It's a distribution of our samples. All right, so I'll pass it back to Frank, who will continue giving us more ideas about course changes and how we can focus our current Year 11 students towards 2016 preparation. So it's back to you, Frank.
Okay. Whoops. Okay, thank you for that, Peter. And as I said earlier, by doing the sort of simulation that Peter has just demonstrated, you're not only preparing students for Methods 3-4, but also for Specialist 3-4.
You just need to share your desktop there, Frank. We've got the ball back to you, but...
Oh, okay. What's happened? I thought I had. Okay, we'll try again.
If at first we don't succeed, that's it. It worked.
Oh, okay. Oh, sorry. That. Okay.
And there's that random desktop lotto that I talk about. It'll land on almost anywhere.
Oh, well, we're there now. Okay. Now, specialist maths, major content changes. So remove content includes hyperbolas and ellipses as a separate topic has gone. However, of course, these could still arise in, say, vector calculus or somewhere else, but certainly it's not there as a separate topic. There have been several minor topics have been incorporated into a single topic on simple rational functions, and I guess the idea would be that it will be a more efficient way of going through that material. Graphs of regions of the complex plane have been removed, and limiting equilibrium when a body is at rest. Right, so what has been added? Well, there's a whole new area of study, which is, the minor addition is the absolute value function, and the major addition is probably... I would have thought
there was a very positive addition to the course there, Frank.
Oh, yes, yeah, positive.
Yeah,
but
very positive. Sorry.
Yeah, absolutely.
oh no, it's regressing.
Yes, it is. That's right.
Yes, and the participants are laughing at us now. Sorry, we'll continue.
Okay, thanks, Peter. Now, the major change is the probability and statistics area of study, which involves, first of all, linear combinations of random variables, which teachers might have been doing in methods anyway, but I guess the major one is the statistical inference with the sampling distribution for means, which is exactly what Peter was illustrating. In the case of methods, it's sampling distribution for proportion. So you're interested in, say, the proportion of the population that has a particular attribute, whereas in specialist, it's the mean. of the samples. Confidence intervals for the means, and hypothesis testing related to the mean. Now, the other change, I guess, is the assessment changes. Now, this applies to all studies. So school assessed coursework in all 3-4 studies is now only based on 2 types of tasks: application task, as is currently the case, and modelling and problem-solving tasks. So in addition to that, the task specification has been made more explicit, so that teachers are, I guess, there should be less confusion as to what is expected. The test task type, which used to be there in specialist and methods, that's gone. And the modelling or problem-solving task replaces all the former analysis task types. So it's no longer an assignment or a set of application questions or whatever. It must be a modelling or problem-solving task. In further maths, the application task is a guided investigation on, as is now, on data. The modelling problem-solving must refer, in Unit 3, must refer to recursion and financial modelling. And you can see all the details in the study design. The modelling problem-solving tasks must relate to the modules, so that is just common sense. In methods, Unit 3, as is currently the case, the application task will be based on functions and calculus. However, the 2 tests has gone. Perhaps it was considered that having tests in there was sending the wrong message, that the idea of school-assessed coursework is that it's testing things or assessing things that cannot readily be tested in the exam. So that's similar to what is currently the case. And instead of the analysis tasks, we now have 2 modelling problem-solving tasks, and one of them must refer to, or must relate to the probability and statistics area of study. Specialist maths, similar to methods, whereas Unit 3, it was the 2 analysis tasks that were undertaken. Now the application task is to be undertaken in Unit 3. The time allocation is now more explicit, must be 4 to 6 hours, and it must be an investigation related to a theoretical or practical context. The weighting and so on is similar to what is currently the case. In Unit 4, we no longer have application tasks. We no longer have analysis tasks. We now have the 2 problem-solving or modelling tasks, and one of them must relate to either mechanics or the probability and statistics area of study. And there's more specification about what a modelling or problem-solving task should look like.
Now, just a clarification of that one, Frank, you've got, and maybe people will have to refer directly to the study design if we're not sure, you've got problem-solving tasks 1 and 2 to relate to mechanics or probability. So does that mean someone could do, and not that I would recommend it in any way, do 2 problem-solving tasks on mechanics?
It says 1 of the modelling. That's interesting. Does it mean 1 or exactly 1? That's just copied straight from the study design.
Yeah, that's a little ambiguous.
Yes, I suspect that it means exactly 1, but yeah. I'm not sure. Perhaps if people have that query, I think David Lee Lancaster would be the person to contact, and he actually has his contact details in a number of the documents to which I've got links in that second page. So if you have any questions, if you have a look at the study advice link on my second page, it's got David's contact details there.
The other thing, just as a couple of comments, in terms of obviously in the time that we have allocated, because we are almost out of time, we can't cover every single change, because one comment that has come in is that constant acceleration formulas are out for specialist. Arc length is in, and the dentists will be happy to know that concavity is now included, pardon the pun. It is getting time. And separation of variables for solving DEs, and coefficient of friction is out. No more mu, no more cats, in more ways than one. So there's a couple of comments about what's sort of in and out, and as disclosed at the start of this webinar, we're trying to cover the broad base, and Frank has included a copy of all those URL links in there for those people that want to get more details. So we're just covering over the surface, so you know the basics of what's in and out. Sorry, Frank, keep going.
And that's why I think I said that at the outset, and I've included that they are only what I see as the major changes.
That's right.
Look at the nitty-gritty, you really look at the study design, and also, as I said earlier, Texas Instruments will be running subject-specific PD through the rest of the year, and I imagine into next year. So this is only broad brush. I'm not trying to cover the fine detail. So yes, I acknowledge that there are other changes, including Newton's method's another one that in methods 1, 2 that a lot of people don't seem to realise is there, or bisection in methods 1, 2. But I thought they were not the really important ones at this stage. I tried in the 45 minutes available. I tried to cover what I thought were the most important ones, but certainly not everything. And lastly, what might you do to prepare students for the new assessment regime for school assessed coursework? Well, my suggestion is to just look at what Outcome 3 says, which is that gives students the opportunity to select and use numerical, graphical, symbolic and statistical functionalities of technology to develop mathematical ideas, produce results, carry out analysis in situations requiring problem-solving, modelling or investigation techniques and approaches. And this is where I think having access to TI-inspired technology makes this really easy to do, as Peter has demonstrated. So I think that brings us to the end of our time. So thank you very much.
It does indeed. All right, so I know we're out of time. If people have any further questions, they can certainly email us. And we thank all of those people who have joined us today. And please be aware that we will be doing more webinars similar to this on our VCE courses, and also on a whole range of other topics. We've got NAPLAN ones coming up. There's one on formative and summative assessment in about 2 hours' time. So if you're really keen, you can jump on board that one as well. I'd really like to thank Frank Moyer for all the work he's done preparing all of those slides for us today. Huge amount of information to get through, and I think we've packed it in with only about 3 minutes over time. So that's all for today, and if you want to review this webinar, it will be available for download by the end of this week. Thanks very much, everyone. Thanks, Frank.
Thank you, Peter.